Welcome back. Section 2.7 Solve absolute value inequalities. By the end of this section, you'll be able to solve absolute value equations, solve absolute value inequalities with less than, solve absolute value inequalities with greater than, and solve applications. Let's recall the definition of absolute value. The absolute value of a real number is its distance from zero on the number line. The absolute value of a number n is written between vertical lines. Absolute value of n, and absolute value of n is greater equals 0 for all real numbers. Absolute values are always greater than or equal to 0. Notice, what is the distance of 5 from 0? It's 5 units. So, absolute value of 5 is 5. What is the distance of negative 5 from 0? That's also 5 units. So, absolute value of negative 5 is also 5. Absolute value equations for any algebraic expression u and any positive real number a. If absolute value u is a, then u is negative a or u is a. Remember, absolute value cannot be negative. For example, let's solve these. Here we are on section 2.7, example 2.68. A. Solve for x. Absolute value of x is 8. What did we just say? Absolute value of anything is a positive or non-negative number, then x equals 8 or x equals negative 8. That's it. We have solved for our equation, absolute value equation. Okay, let's try another one. Absolute value y is negative 6. Absolute value can never be negative, so there is no solution. That's it. Here is another example. Absolute value z is 0. Well, the only way absolute value of something can be 0 if that something is itself 0. All right. Next, let's try 2.135. Absolute value x is 2. Absolute value of any expression is a positive number if and only if the expression itself is 2 or the expression is negative 2. So you have solved for x. X is 2 or x is negative 2. B. Absolute value of y is negative 4. Well, absolute value of y is negative 4. Absolute value can never be negative, so there is no solution. C. Absolute value of z is 0. The only way absolute value of an expression is 0 if the expression itself is 0. That's it. Let's try one more set of problems. Exercise 2.136. A. Absolute value x is 11. Well, That means x is positive 11 or x is negative 11. That's it. Absolute value y is negative 5. Notice absolute value can never be negative number, so no solution. C. Absolute value z is 0. Absolute value z is 0 implies z itself is 0. We have solved for z. Here is a nice example. Example 2.6.9. Solve. Absolute value 5x minus 4 minus 3 is 8. Okay. Now here we require to do some work. So let's start. So the goal is to solve for x. X is within the absolute value. So let me get rid of that 3 first. Add 3 to both sides of the equation. So I have absolute value 5x minus 4 minus 3 plus 3 go away equals 11. This tells me 5x minus 4. So notice absolute value is a positive number. So this is valid. It's okay to continue. So the expression inside is 11 or the expression inside is negative 11. So these are the two possibilities. Either the expression inside is positive 11 itself or the expression inside is negative 11. At this point, add 4. You remember we need to solve for x. So there are two equations to work with. Add 4 to both sides of the equation. So I'm solving this equation first. Okay. So negative 4 cancels, positive 4. So 5x equals 11 plus 4 is 15. Divide both sides by 5. This gives me x equals 5. So this is one case. All right. So that was one equation. Now let's solve this other equation. Here, again, we need to solve for x. So add 4 to both sides. This gives me 5x here equals negative 11 plus 4 is negative 7. To solve for x, we have to divide by 5. Negative 7 over 5. Okay, so that gives you x equals negative 7 over 5. Okay, I can write it with an overall negative because negative over positive is a negative value. So these are your two options. These are your proposed solutions. So don't forget to check. Okay, first you are checking x equals 5, right? In your equation, original equation. So how do we check? We take our original equation. Wherever we see the variable, replace it by parentheses first. You are substituting 5. and you're checking. Okay, so don't forget this is a checking. So absolute value is a grouping symbol, so keep it as it is and simplify inside. You're checking whether all of this evaluates to 8. What happens inside? 25 minus 4. 25 minus 4 is 21. 21, I hope I haven't made any mistakes. Oh, 15 over 5 is a 3. No wonder it wasn't working out. All right. Good. 15 minus 4 is an 11. Absolute value of 11 is 11 minus 3. Is it equal to 8? Yes. Okay. X equals 3 is a solution. Now let's try this number, negative 7/5. So you have your original equation and you want to evaluate it at x equals negative 7 over 5. Okay, so where you see x, you will write parenthesis and place negative 7 over 5. All right. Question is this equal 8? Let's try. Again, absolute value is a grouping symbol that has to be evaluated first. So 5 times negative 7 over 5. 5 reduces, you're left with negative 7 minus 4 inside. So that gives us absolute value negative 11. Negative 7 minus 4 is negative 11. Absolute value negative 11 minus 3. Is it equal 8? Absolute value of negative 11 is positive 11 minus 3. It is indeed equal to 8. Yes. So x equals 7, negative 7/5 is also a solution. And that's it. So we have solution set. We found 2 solutions. One is 3, the other is negative 7/5. Okay, that completes the solution to this problem. Okay, let's continue in our next video.